Okay, here are the practice test free response questions. Here are the practice test free response questions. Hopefully you can hear me now. We have a display of data for temperatures in degrees Fahrenheit for the city of Roanoke in the month of October. That's how many temperatures were recorded. That's the mean, the median, the standard deviations, min, max, Q1, and Q3. Question number 1. Do outliers exist in these data? Use the 1.5 IQR rule for outliers and the summary statistics above to determine whether there are outliers. List the outliers, if any. Well, first, let's get the IQR. IQR is going to be 70 minus 62, which is going to be 8. So 1.5 times that is going to give you 12. As a reminder, there are lower outliers when you take Q1 and subtract that 1.5 IQR, and there are upper outliers when you take Q3 and add that number. And if there's anything below the Q1 minus that number, that's an outlier. Anything above Q3 plus that number, that's an outlier. So if you do some quick math, Q1 is 62. 62 minus 12 is 50. Q3 is 70. 70 plus 12 is 82. So anything below 50 would be considered an outlier. Anything above 82 would be considered an outlier. Well, since our minimum is 27, we know that there's at least an outlier on the lower end. There could be more, but there's at least one below 50. But since our maximum is only 81, then there aren't going to be any upper outliers according to this rule. So since the minimum is 27, we know there is at least one outlier on the low end, but since the max is 81, there are no higher outliers according to the 1.5 IQR rule. Remember that you could, this one said to use that rule, but some rules for standard deviations, if you add or subtract 2 standard deviations to the mean, if you take away 2 standard deviations, anything below 55 would be considered an outlier using that rule. And if you add 2 standard deviations, anything above 72 would be considered an outlier. Well, if you use that rule, then you could argue that there's an outlier on both ends. But according to the 1.5 IQR rule, there are no outliers on the high end. Letter B. Using the formula below, convert the mean, standard deviation, median, and IQR to Celsius. So here's your Celsius conversion formula. Centers and any other location points, specifically like Q1, min, max, Q3, those all are affected when you add or subtract or multiply or divide. So if I'm plugging in my mean of 63.6 into that formula, I do want to subtract the 32, and then I want to take that and multiply by 5/9. You're going to get a Celsius answer of 17.56. Double check that in your calculator. So 17.5 or 17.6 would be fine. That's a center. The spread, adding or subtracting doesn't affect the spread. So we only have to multiply that standard deviation by the 5/9. And that's going to give you 2.3. The median is also a measure of center. That's a location, so that does have to follow both the subtraction and the multiplication. And that'll give you 20.3 degrees Celsius. And finally, the IQR, not the quartiles themselves, but the IQR being 8, that's a measure of spread. So we would only want to multiply that, not add or subtract it. So remember that adding or subtracting doesn't affect the spread, or doesn't affect the spread of the shift. It doesn't affect how far apart stuff is. So whether you shift it left or right, it's still going to be that same width. So we only multiply, because multiplying, in this case 5/9 is going to make it smaller, right? But if you multiply by a larger number, that's going to make it bigger. So those should be your answers for that. And then to wrap it up on part C, what do you think the shape of the distribution would be based on the mean and median? Well, let's look on the mean, or it doesn't matter whether you look at the mean or median here or there. Since the mean is less than the median, you would have to, the best you could say is that data is going to be skewed to the left, okay? Because anytime the mean is lower than the median, then that on the density curve, it's going to look on this side of it. Median would be kind of splitting that halfway there. So the shape of the distribution does not change when the values are converted to Celsius, okay? So it's converted, it's going to be skewed to the left, but the shape will not change when converted to Celsius because shape does not change no matter what you add, subtract, multiply, or divide to it. It's going to be the same shape. The spread will get smaller because you got smaller numbers, but the shape will be the same. All right, question 2 from your free response questions. Men's shirt sizes are determined by their neck sizes. Suppose that men's neck sizes are approximately normally distributed with a mean of 15.8 inches and a standard deviation of 0.8 inch. Calculate the proportion of men whose neck size is greater than 17 inches. Well, again, there's two approaches here. You can do the calculator or table. I like the calculator. So it's going to be a normal distribution. There's your notation. There's a diagram. Always have the notation and diagram. Always have your work. So in this case, normal CDF, it would be the lower bound. Upper bound is infinity because it's going to the right of 17. And you can get that by doing second vars, normal CDF, lower being 17, upper being 1E99. That's infinity. Mean of 15.8 and standard deviation of 0.8. So the percent above 17 would be about 6.68%. Or you can do the z-score. That gets you a z-score of 1.5. Remember, the table only goes below that number. So if you're looking at a z-score of 1.5, 1.5 is going to be 0.9332. And I had to fix the numbers. I wrote down the wrong numbers from the table. So let's resume that. 1.5 is at 1.5 is 0.9332. Remember that a z-score on the table is going below it. So since this question wants to know above a number, we do have to subtract that from 1. So 1 minus 0.9332 is 0.0668, same as I got from the calculator. And look, I'm just going to be straight up. I got the wrong number from the table because I was looking at the wrong row or column. So it's much more accurate to probably use the calculator when you're doing this. Summarize it. So the proportion of men whose neck size is greater than 17 inches is approximately 0.0668 or 6.68%. You always got a summary. Part B. Find and interpret the standardized score for Austin, whose neck size is 17.5 inches. Standardized score is a z-score. That's the same thing. So since this question wants you to find it, you do have to know the formula. X minus the mean divided by the standard deviation. That's going to get you 2.125. That means that Austin's size is going to be a little over 2 standard deviations above the mean of 15.8. So just to summarize it, this is more than you probably have to put, but just to kind of give context to everything as much as possible, Austin's standardized z-score is 2.125. This means that his neck size is 2.125 standard deviations above the mean of 15.8 inches. It wouldn't hurt to interpret what that means. So from table A or the calculator, this puts him at about the 98.3rd percentile. His neck size is larger than about 98.3% of the population. And if you want to get that from the calculator, you just go Second var is normal CDF. Z-score is everything below a number, so a -1 E99. Your upper bound would be your Z-score, which is 2.215 or 2.125. When it's in the Z-score, your mean is 0 and your standard deviation is 1. And there's your 98.3%. The table would give you the same thing if you looked for that Z-score. So he's got a very large neck compared to everybody else. And our last question, how big is the neck size of the top 10% of neck sizes? Round your answer to the nearest tenth. Well, top 10%'s up here. Remember, for our calculations, we're looking below that same number. So we're going to subtract the 10% from 100% to get 90%, 0.9. I like to use inverse norm for these. So I just say inverse norm area is 0.9, mean of 15.8, and standard deviation is 0.8. And that's going to give you a neck size of about 16.825. So I just round to 16.8. So to interpret it, any neck size at or about 16.8 or above, because remember this question says top 10%, and you have to include the ones above it because they're in the top 10% as well. They would be in the top 10% of neck sizes. So this or above is important. That's going to get you full credit on a problem like that.